G'day from Australia. As is our custom here, I'd like to begin by acknowledging the traditional owners of the land from which I'm broadcasting. I'd also like to pay my respects to elders past and present. My name is Ashley Davis. I'm the author of Bootstrapping Microservices, and today I'm going to continue my talk about infrastructure as code. Last October I did the first part of this talk. In the previous talk I demonstrated creating a Kubernetes cluster using Terraform. We created infrastructure for an application through code, and that's why it's called infrastructure as code. I then automated creation of the infrastructure by wrapping it up in a continuous delivery pipeline. That meant we could push code changes to update our infrastructure and thus fulfilling the ideal of infrastructure as code. I'm going to show you where you can watch that first talk. So this is the second talk. I'm going to show you where you can watch that first talk soon. If you'd like to see how to automate deployment of infrastructure, and it's not as difficult as you might think. Today we're moving on to the second part of it, which is to basically build a microservice and publishing it using Docker, and then deploying it to our Kubernetes cluster using Terraform. Just give me a moment and I'll share my screen with you. So after the previous talk, you can see a link on screen there if you want to watch that later on YouTube. Also, this live stream will be on YouTube as well later. So keep an eye out for that if you don't get time to watch it all today. So we've already created an empty Kubernetes cluster. By itself, that's not very useful. So in today's talk, I'm going to show you how to use Docker and Terraform again to deploy microservices to that cluster. I'm going to demonstrate how to do this on my computer. So I'll run through the process sort of manually, but ultimately I'll show you how to kind of wrap that up in a continuous delivery pipeline. So we'll have our deployment of our backend on automatic by that stage. We'll be able to make our code changes. When we push those code changes to our hosted code repository, that's going to trigger the automated deployment pipeline to build, publish, and deploy a new instance of the microservice that we just updated. I'll start with a little bit about myself first, just so you know who I am. I'm the CTO of a startup called Sortle. We have a product that helps you organize your digital assets through the magic of machine learning. I'm also the developer of DataForge Notebook, and it's like Jupyter Notebook, but it's for JavaScript and TypeScript. You can prototype your code with live visualizations and later export your code to use it in production. Of course, I'm also an author with Manning. I've written 2 books now. This is Data Wrangling with JavaScript. That's my first book. And it shows JavaScript developers that, to work with data, you probably don't need to resort to Python. Most of what you need for working with data is already available in JavaScript. You just need to learn how to use it, and my book will show you how to do that. And my latest book is Bootstrapping Microservices. It's a practical and project-based guide to building applications with microservices using all the latest tools, and of course focusing on Docker, Kubernetes, and Terraform. In this book, I'll lead you through a complete process of building a small but complete microservices application. We start with just a single microservice, which we package and publish using Docker, and then we ramp up to multiple microservices, simulating a microservices application locally using Docker Compose. Eventually, we create a Kubernetes cluster, deploy our application to it, and we do that using Terraform. The content you're going to see in the presentation today is very much related to my book. The previous talk actually was based on chapter 6 of my book, where we build the Kubernetes cluster. Today's talk is related to multiple chapters. For example, in chapter 3 of my book, you learn how to build and publish Docker images. And in chapter 7, we basically deploy those microservices to the Kubernetes cluster. And we automate it all by creating a continuous deployment pipeline. So if you'd like to see more of what I'm going to show you today, you can definitely find that in my book, Bootstrapping Microservices. Please hang about until the end. I'm going to be giving away discount codes so that you can get the book for much cheaper. So I'm just going to give you a little bit of a demo of where we're heading in this talk, just to cut straight to the chase and show you what the end goal is here. Before we do that, I'll just show you on YouTube where you can find the previous version of this talk. So if you go to my YouTube channel, The Data Wrangler, so that's on YouTube. If you go to the all videos list here, scroll down. Oh, by the way, there's a bunch of live streams that I've done here. These aren't Manning live streams. This is my personal live streaming channel on Twitch, and I'm doing that every week. So I'm live streaming regularly my coding. Please come and have a look. I'd love to show you what I'm doing. But if you scroll down here, you'll see Infrastructure as Code live stream. So that's part one of this talk, and that's what shows you how to use Terraform to build your Docker container registry, and also how to build your Kubernetes cluster. And today we're going to be making use of that infrastructure to deploy microservices. Now there's a code repository for this on Bitbucket. Look under Bootstrapping Microservices. There's two public repositories here. There's example one. That's the example of how to deploy the Kubernetes cluster using Terraform. That's what I covered in part one of this talk. Today we're going to be focusing on example two. So if I just open that up. So this is just a code repo. It's like what you'd find on GitHub or GitLab. Bitbucket is just another way of storing code online. I started using Bitbucket because it had a nice free tier for running continuous delivery pipelines before GitHub did. So that's the reason I'm sort of still on Bitbucket for this. But you can do very much the same thing I'm going to show you today. You can do it on any hosted Git repository service like GitHub, GitLab. Even if you just want to try this on a completely separate continuous delivery pipeline platform, you can, like Travis CI or Circle CI. Can't remember any off the top of my head, but a lot of the providers these days for this sort of thing, they all use a similar YAML format to what I'm going to show you today. Now, I'm just going to drill down to the Pipelines tab here. So this is where I've been running my continuous delivery pipeline for this code repository. This is just a simple example. It's a trivial example, much simpler than what you'd find in production, but that's good. I mean, that's good for a demo, right? I just want to show you how simple this can be to get started with. You can see I've got a bunch of pipeline invocations here. Many of them have failed, many of them have been successful. Pretty much all of these has just been, since I did part one of this talk last year, I've just been running tests against this to make sure it still works. So what I'm going to do now is I'm going to make a change to the code that I've got running already on my Kubernetes cluster, and you're going to see a new continuous delivery pipeline be invoked, a new instance of it, and that's going to roll out a change to my Kubernetes cluster. Before we do that, I'm just going to show you what it currently looks like. So I'm just running, I've got kube control installed already. This is the Kubernetes CLI tool. I've already got it authenticated with the cluster that I created, exactly like what I created in my last, in part one of this talk. That's what we're starting with. I'm going to look at the services. Oop. Helps if I spell it right. Kube control, get services. Okay, so this just shows me the services I've got running. You can see my video streaming pod that I've got running on Kubernetes. So that's a container that's been deployed from my private container registry. I've got it set up so that it is on this external IP, so I can actually copy that. I can open up a new browser tab. I can paste that, and you can see, pretty simple, it displays "Hello World." Nothing too exciting there. This is actually a simple sample of a video streaming application, though. So there is another route there that's video, so we can actually look at that and watch a video being played. Now what I'm going to do is I'm just going to, as a simple example of how continuous delivery works and how easily I can just invoke it while I'm coding and deploying code, I'm going to update this. I'm going to update the application that's behind this that's running. This is all running on Azure, by the way. So the Kubernetes cluster for this is running on Azure, but Kubernetes can run on any cloud provider. So it doesn't matter whether you want to use AWS, Google Cloud, DigitalOcean, Linode. There's a bunch of other smaller ones as well that support Kubernetes. So Kubernetes is just great for that sort of building cross-platform applications where you don't want to be locked into any particular cloud vendor. Okay, so I'm just going to go into the code repo. Oh, that's the wrong one. I'm just going to go into the code repo that I've already got running here, or sorry, downloaded. I'm going to open up Visual Studio Code from this directory. It's just appeared on the wrong screen. Let's bring it back. So you can see here I've got here's the root route that's saying hello world. This is an Express.js app running on Node.js. This isn't about Node.js really. Like you can run anything in Docker, obviously. So just try and pretend like if Python's your thing or Java's your thing or whatever, just pretend that I'm showing you Java code or Python code right now instead of JavaScript. Here's the video route. So that's what we just hit when we were looking at that streaming video a moment ago. Just to pretend we're making like a production change here. Let's just change this to Hello Computer. That's a good little change. Hopefully everyone can see that and it's clear on screen. So I've just updated that from Hello World to Hello Computer. That's all. I'm going to commit this change. Just have a look at my Git status. So I've got one file modified like a good coder. I'm just going to diff it. I'm just going to have a look at what was there, what I'm updating. That's just so that I make sure, just to double check, sort of like a self-review, just to make sure I'm not breaking anything. Obviously I'm not breaking anything. This is just a really trivial case, but just interesting to look at the, the actual process that I use. So I'm just going to stage that change. I'm going to commit it. Not a very good comment, but I'm trying to get through this quickly. So I've committed that. I'm going to push this up to my Bitbucket repository. We'll switch back to Bitbucket. If hopefully, fingers crossed, pray to the demo gods that we're gonna. Yep. Oh, it's come through for me. Awesome. So the new pipeline is in progress. You can see the comment here. Update to the web server. We can drill down into that and have a look what's happening. So this is running through a series of steps. At the moment, it's just cloning the code repository so it can actually work on it. Now it's running it. So you can see here the actual commands it's using to clone the Git repo into this continuous delivery pipeline. Hopefully this is not going to take more than a moment to actually get into the good stuff. Okay, let's just let that run for a moment, and then we'll come back to it. In the meantime, let's move on with the slides. Okay, so I'm trying to give you a bit of a taste of where we're heading today. We'll check on that in just a second. So the continued theme of this talk is infrastructure as code. Now, I fully explained that in the previous talk. So today we're just going to do a quick review of it. We're not going to spend a lot of time going into a lot of detail. You can catch up on part 1 on YouTube for that if you really want to look into that. I'm going to be giving a bigger live demonstration that shows you, the taster that I'm giving you at the moment. I'm going to show you how we get to that point and the work that we have to put in. And that means deploying microservices to this Kubernetes cluster using Docker and Terraform. Right, before we get into what infrastructure is, let's just see where we're at here. Okay, this is still running, so this can take some time. Like I said, I'm running on a free tier of Bitbucket here, so they're probably not giving priority to my job here. But let's come back to this. So before diving into infrastructure as code, let's briefly take a step back and understand what I mean when I say infrastructure. Infrastructure is simply the platform on which we run our application. For this particular example, the application is one that has been built with microservices. It doesn't have to be that way. Just because you're using Docker and Kubernetes doesn't mean you're using microservices. You can be using a monolith. You can be using, the developer's utopia of microservices, or somewhere in between, which is more common, right? You can have a distributed application made out of big services. You can have one monolith, and you can have multiple services next to it, supporting it. However you want to structure your application, that's fine. I'm particularly into microservices, so that's sort of what I'm focusing on. You can see in this diagram that we have a bunch of microservices running on a Kubernetes cluster that is hosted in the cloud. And you can see off to the left that we have a user. They're interacting with our application through a front end in a web browser. Otherwise, they could be interacting with our application in a mobile device or some sort of IoT device. It doesn't really matter. So the infrastructure in this example is running on a Kubernetes cluster, and that is the computing platform that I use in production, and it's what I'm talking about today. Obviously, in the first part of this talk, like I said, you can watch that on YouTube. We showed how to build the Kubernetes cluster, so I'm not covering that today. We just assume that we've got a Kubernetes cluster ready to use, and what we're looking into today is how to put those microservices in place in the cluster. Now let's just have a quick look back at my job. Wow, this is really running slowly today. I'm just going to refresh the browser and just see if it's sort of got ahead where and not caught up. Oh wow, no, it still says it's cloning. Anyway, that could still take a little bit of time. I'm still hopeful that that's gonna complete. Hopefully you're all praying to the demo gods for me for that to work. I'll move on with the slides. Hopefully by the time we get to the full demonstration, the taster demonstration will be finished. Now, we could build the infrastructure and do our deployments manually. We can either use the GUI in the cloud vendor, or we can use the command line tools provided by the cloud vendor. Manual deployment, it's a great way to get started. It's a great way to learn. It's a great way to just teach yourself, what you need to know in order to get to the automated part, right? And it's also perfectly okay to start a new application, any new application, even once you're experienced, right? Start any new application by manually creating the infrastructure. You've got to write that code first somewhere, right? You can't just write the code, pages and pages of deployment code and stick that in the cloud and hope it's going to work. I mean, you've got to test that locally anyway, right? So you've got to go through a process of, learning how to create a cluster through the command line, and then learning how to create a cluster through Terraform. And then once you've got that set up, you can prototype the code for your application and get it running on automatic. Manual deployment might also be all that you need. Like if you know what you're doing, if you're just deploying the infrastructure once and you're not going to update it again, or you're not going to update it very often, then it's okay for you to work that way. Like I'm not saying that automation is essential. At some point to scale, yeah, you got to automate. But if you're working with a small infrastructure, a small application, you might be able to get away with manual deployment. Obviously, there's a lot of problems with manual deployment. As your application grows more complicated, the deployment process grows more complicated. And as the deployment grows more complicated, if you're doing manual deployment, it means you've got a human doing it, and obviously they're going through a complicated series of steps. The risk of human error is going to grow, and the manual process becomes less reliable, less repeatable, and not to mention the fact that it's taking more and more human effort. You're basically paying for your humans to do that, the people that are working for you to do that kind of repetitive, tedious work. In the end, manual deployment just isn't very scalable. So as your infrastructure goes bigger and more complicated, manual deployment, it just doesn't work so well. Now, the solution to manual deployment, of course, is to automate it. I've listed here numerous advantages of automating your deployments. In the previous talk, which you can find on YouTube, I go into this list in a lot more detail, so please have a look at that talk if you're not convinced. If we automate our deployments, it means we can do reliable and fast deployments whenever and wherever we like, and as often as we like, without having to wait for any human to put in the hours, and without incurring any mistakes from human error. So taking humans out of the loop saves time and money, and not to mention that manual deployment is just a really boring job. So instead of having our ops people do it, they can be doing something else that's more interesting and adds more value to the business. Okay, before we take a look at what this continuous delivery pipeline in the diagram means, I'm just going to go back and check where we're at here with my deployment. Wow, they must have really bumped down the priority of my my free process here that I'm running. Okay, let's move on. So this diagram shows where we want to end up with infrastructure as code. Now, the infrastructure code that we created and tested locally, we're going to get that running in our automated continuous delivery pipeline. You can see the developer here on the left is writing and testing their code locally. They're committing code to their local Git repository. When they push code changes to their hosted repository, that automatically triggers the continuous delivery pipeline that you see here. In the demonstration today, of course, I'm going to be on my local computer demonstrating Docker and Terraform, getting that through this pipeline means you're automating your deployment process. Like you're aiming to create a really fluid flow of code changes going from the developer into production. Now, obviously, this is a really simple pipeline. I haven't illustrated that there should be any checks or balances here. In a real production commercial application, of course, you're going to want to have some automated testing in the pipeline as well to make sure things are working before it's allowed to go live. And you probably going to have some manual steps here for approval, so that code can be reviewed. There can be some manual testing done on the application before someone hits the button to make it go live. Typically, and I explain this a lot in my book, Bootstrapping Microservices, typically I'll use multiple branches to do that. So I'll have a dev branch where the developers are working every day. I'll have a test branch. Merging to the test branch automatically pushes to a test cluster. And then I'll have a prod branch or a live branch that automatically pushes to the live cluster that is customer facing. So doing those manual merge steps is the kind of the pushing of the button, but you can set that up any way you like. You can literally have an actual button, in an admin portal somewhere that can deploy stuff if that's what you want. But using branches in a Git repository is a great, simple, straightforward way of doing that. So this pipeline makes for a complete automated flow of infrastructure from the developer all the way through to production. So hopefully you can kind of see why it's called infrastructure as code. At no point in the process are we kind of manually, creating any infrastructure. We're not manually doing any deployments to Kubernetes or anything like that. We're not going to use the Kubernetes CLI to do that. It's all automatic and done through code. So before we get to the full demonstration, I'm just going to do a quick review now about infrastructure as code. The main thing to remember is that we're essentially making the building of our infrastructure into a coding task. So infrastructure as code, just think of it as managing your infrastructure through code. Anything then that's useful for coding also becomes useful for building infrastructure. And that's really important because we've amassed a massive toolkit of techniques for coding that we can now apply to creating infrastructure. So like I'm talking about, just the fact that I'm using versions in a Git repo to manage the code for my infrastructure. It's versioned, I can do code reviews against that. I can go back in time if I need to. It's code, and I can run automated tests against it. I can run automated tests against my infrastructure code. Isn't that amazing? So anything that's been good for coding, all the stuff, over the decades where we've built up processes and best practices for coding, most of that, if not all of that, can be applied to coding against infrastructure as well. And again, if you want to go into more detail, please look up the first part of this talk on YouTube if you want to go deeper on what infrastructure as code is. And I talk a lot about that in the first video. Okay, we're on to the full demonstration. I got to go back to my small demonstration and see what's happening there. Okay, let's have a talk about what I was hoping to show you here that's just not coming through for me at the moment. It's never taken this long before. So once this completes, once the pipeline completes, what I expect to see is like the previous run that oh look, it's saying successful. That is really strange. So there's like something wrong. There's something wrong with this web page. I'm just going to close that because it says it's successful 30 minutes ago, and I've been sitting here waiting for it to complete. It completed in 39 seconds, but for some reason, the progress in that other web page wasn't updating. Let's just have a quick look down here and see what happened. Wow, there must be something wrong with this because it's still in that stage where it says it's cloning. Anyway, we can't get down to that web page, so we can't see exactly what it did. But I'll tell you what it did. It built a Docker image. It pushed that Docker image to my private container registry, and then it deployed that image as a container into my Kubernetes cluster. And we should be able to see the result of that. So you can see previously this said hello world. If this has indeed worked, and there's no guarantee that it has, let's refresh that. Hello computer. So that actually worked, even though it just went a bit weird there. But what that means is that, to get a code change into production, I just committed it to the Git and I pushed it. That was it. Like at the end of the day. So hopefully you can see how setting up infrastructure as code, setting up continuous delivery pipeline is going to make for a really fast and fluid flow of development. So it can take a bit of effort. It can take a bit of effort to get all this infrastructure and all this automation working. I've got it down to a fine art, right? Like I can get a back end and a CD pipeline up and running within a day. And the recipe that I use is in my book, Bootstrapping Microservices. If you're just new to this, you haven't got the experience, it's probably going to take you a bit more figuring out than that, obviously. But you put in that time, you put in that effort, and then you're just coding. You're coding and the code flows. It flows into the Git repo. It flows into the hosted Git repo, and then it flows into production automatically. If you're a bigger company, if you're a startup, that kind of bare metal kind of get the code straight out of the production can work really well. But you can also have a test. You can also have a test cluster, right? Your code can be going live into a test cluster where your developers can be testing it. Before your senior developer, before your lead developer, or before your product owner merges that code to production and automatically pushes it out to the live customer-facing Kubernetes cluster. Okay, so now we're up to the full demonstration. That demonstration, which was a little bit awkward, that was just a taste. That was just the end product. Now I'm going to show you what it takes to get there. We're going to be building our Docker image locally on the machine. We're going to be publishing it to the container registry. So we're going to use the Docker command line tool to do that. And then we're going to deploy the container to Kubernetes. And we're going to use Terraform to do that. And then obviously at the end of all that, I'm going to show you how we wrap that up in the continuous delivery pipeline. So what I'm going to do is I'm just in my working demo directory here for the demo. I'm actually running on Windows 10, but I've got Git for Bash installed, which comes with a whole bunch of Linux tools. That's why I'm using Linux commands onto Windows. It works really nicely. I'm using Windows Terminal, which is available on the Windows application store, or whatever it's called, the Microsoft store. It's really good, much better than the console emulator that you get built in with Windows. So I definitely recommend you get Windows Terminal from the Microsoft Store and get Git for Bash, or Git for Windows. It comes with Bash. It comes with all the Linux tools. And what I'm going to do is I'm just going to clone this fresh. So if you wanted to follow along, you can do this as well. So again, I'm on Bitbucket under the Bootstrapping Microservices organization under example 2. You come to the main page here and you can click clone. That'll allow you to copy the command. You need to clone this. So that's a Git command. It's going to clone this locally. Obviously, I've already got a copy of example 2. In fact, I've got 2 copies of example 2 locally. So I'm going to make a third one and I'll just call it working. Okay. So I'm going to clone that locally. This shouldn't take too long and it's done. That's awesome. So go down into working. I'm going to open Visual Studio Code on this directory. Now, one thing I have to do here, actually, I'll come back to that. There's no reason to do that yet. So what we've got here, basically, open in Visual Studio Code, is a fairly basic, fairly typical Node.js microservice. This can be any code. This could be Java. It could be Python. So please just pretend that I'm working with your favorite programming language, because this is about Docker and Terraform. It's not about which programming language you use to do microservices. We've got the basic Node.js stuff you need here, like package.json, which contains the dependencies and metadata about the project. We've got two Docker files. We're going to look at those in a moment, a dev version and a prod version. I'll explain why we need two in a moment. If you're just getting started, you can get away probably with just one Docker file. But I have different needs for development and different needs for production, and that's why I have two separate ones. We've got a configuration file here. That's a YAML file. It's a configuration file for Bitbucket pipeline. So that's where we configure our continuous delivery pipeline. Under source, we have the source code for the microservice. It's just a simple, let's have a quick look at that. That's what we're looking at before, basically, where we changed hello world to hello computer, which you'll see just here. So it's just a small, simple, really trivial microservice implemented in Node using JavaScript. Under the scripts directory here, we have various Terraform files and a couple of shell scripts to help us as well. So we're going to come back and we're going to have a look at the code that's in those in a moment. But first, I'm going to show you how we build this. So I've got Docker Desktop for Windows installed, but it's actually using the WSL2 Linux, what do you call it, like sort of backend for Windows. Like, it allows you to get basically any kind of Linux flavor really running directly under Windows. So Docker uses that. So it's not. I'm not running Windows containers. I'm actually running Linux containers, but in an Ubuntu WSL2 VM under Windows. If you like working in Windows, it's a great way to work. It might sound complicated, but you can trust me. It's fairly easy to set up. I've deleted all my local images. So when I do Docker image ls, normally I'd have a big list of images here that I had cached locally or that I've been building locally. Before this session, I've deleted all those just so we can keep it simple and you can see what I'm doing. And now I want to do the Docker build command. I'm going to tag it. I just have to, just off to the side here, I've got a cheat sheet where I've got all important URLs and stuff like that. So I'm just going to have a look in here and see if I can find the address of my my Docker registry. Oh, there we go. So I'm just tagging this with the registry that I want to push to. And what else do I need here? I need to give it a name. So the pod that I already had running, which is the same pod as I'm about to deploy, and I don't want them to conflict. So I'm calling this pod, instead of video streaming, I'm just going to call it video. I should really call it video dev or something, but it doesn't matter. This isn't production. This is just a simple example that I'm going to delete after this session anyway. And now I need to tell it which file to use. So normally you don't have to do this. It will just default to a Docker file, but I want to tell it to use my Docker file prod. So I'm using the prod version of the Docker file. I'm telling this dot at the end tells it to work with the current directory. So this is going to take a moment because what it's doing now is it's pulling down my base image. I should really update this to a later version of Node, but I'm using Node.js 10. I'm using the Alpine version of that. So Alpine Linux is a cut down version of Linux, which is smaller for production. So really good if you want to reduce the size of your Docker images that you're building. So you can see here that it's, it went pretty quickly there, but it installed production dependencies. We're going to have a look in the Docker file in a moment to see how this all works. It's copied source code in. We're hard coding some videos. You see here it's copying the videos. We're hard coding them into our Docker image. Now, if you're making the next Netflix, obviously you don't want to hard code videos into an image like this. They're going to be stored in some database somewhere. But just for this simple example, we're basically baking one video into our Docker image, and that's the video that we're playing when you hit the video route on the web page. Now, what was I going to say? Anyway, you see here the command for actually starting the microservice, npm start. That's the conventional command basically for starting a Node.js application. If I do a Docker image ls now, you can see that I've got the Node base image. That's the version 10 of Node. And I've got this specially tagged image here. You've got the unique ID for the image here, which you can use to kind of do things with that as well. Now, I want to publish this image somewhere where I can get to it in the cloud so I can deploy it in my Kubernetes cluster. The first thing I've got to do though is I've got to log into my Docker registry. So I'm going to use the Docker login command. Again, I've got to just find the URL for my registry. Now, if you're thinking this is a bit of a pain, having to type all this stuff in at the command line, yep, that's why we automate this. And I'll show you how this is automated after I've showed you the manual process. So now I type in my username, which is IC demo, and I'm just going to give my password away to everyone. No one's going to abuse this, are they? Hopefully not. It doesn't matter anyway. I'm going to wipe out all this after this. After this demo is complete, this will all be gone. So I'm just logging into my container registry. Now I'm going to use the docker push command to push my local version of this image up to my registry. And we called it version 1. This is version 1 of this new container. Actually, I might have to. This isn't going to work. I think I've actually already got a version 1 up there, right? So I'm just gonna retag it or rebuild it with a new tag. Let's say we're working with version 10. We've jumped ahead in time. We're working with version 10. I'm gonna now. I'll do my docker push now. Version 10. So this is now being pushed up to my private container registry that I've got running on Azure. You can run container registries anywhere. You could run it on your own machine if you want. You can run it on any cloud vendor. It's I've actually been playing with building these things manually recently, and there's on Docker Hub. If you search for registry, you'll find the official image for the Docker registry. That's by Docker themselves. So you can set this up from scratch pretty easily if you want to. But there's a whole lot you've got to consider, obviously, with security, if that's the case. Now we're going to before we get to Terraform, let's have a look at the Docker files that we just used. So this is the prod Docker file. The first line here shows you the image that this is based on. So it's based on Node.js 10 using Alpine Linux to cut down the image size. Then we set a working directory to work within for the build process within the Docker image. We're copying across the package file and the package lock file. That's what we need to install dependencies. And then we're installing dependencies. So this is installing using npm, the node package manager, to install dependencies. This bit here, only production, is basically saying we only want the production dependencies. We don't want any of the development dependencies. So that cuts down what we're going to install. Having a more minimal footprint for our images for production is good. Then we're copying across all the JavaScript source code. I mean, there's only one file, there's only one JavaScript file there, but if you had more, they would also be copied across. Then we're copying across the videos. If we have a quick look over here in the videos directory, you can see that's where my sample video is, an MP4. It's just a really small video, so just good for testing. And then the command here is basically what we run to start this application within the container. And we can see where this start script is implemented if we go to package.json. So we're just looking at package.json now. You can see that there's a start command here. So when we run npm start, it actually runs this little snippet of command here. So it's saying to run node with the main source file for this microservice. Now there's also start dev. So that's where I use nodemon. It's similar to the previous command, except we're using nodemon instead of node. And what that's doing is it's going to restart the microservice whenever the code changes. That's really important. That's live reload. It's like hot reload for within your container. So when I start a development version of this, which I don't talk about, I don't have time to talk about that really today. You can find out how to do that in my book, Bootstrapping Microservices. But when I run a complete microservices application on my local computer, I'm doing that using Docker Compose, and I've got it set up for live reload across the entire application. So for each microservice, I'm using nodemon, and then the difference with the dev Docker file is that we don't copy the code across. Nowhere here do you see the code being copied across. And in fact, we don't even bake the dependencies into the image. So what we're doing here in the start command for the container, we're setting up the Node.js cache or the npm cache for caching dependencies, and we're doing the install at startup time. And the reason for that is because the way this is working, we'll be able to kind of, using shared volumes, we'll be able to share the npm cache with the host operating system. So we're persisting the cache. So every time we build a new image and we start a new container off it, we're going to reuse the same downloaded dependency. So that makes startup of a container a lot quicker. And it makes building the container a lot quicker as well, because installing dependencies in an image while you're building it is one of the slowest parts of this. And then of course we run the application, the microservice, with this start dev command. So that's what enables NodeMon. Now, the thing we're missing here that I'm not showing today is the Docker Compose file that sets up the sharing of the volumes. So that's in my book though. So if you're interested in how to get a real efficient development process working, live reload for your whole microservices application, please have a look at my book. You can read the first chapter free if you go to the webpage. I'll show you that at the end of this. So that's the Docker file that we just built. Sorry, the prod version. We'll go back to that. This is the Docker file that we just built. We built an image from that. We looked at it using Docker image ls. Let's see that again. So that shows your local images. You can see we've got the previous version 1 that I tagged, and also the version 10. But I think I'd already kind of published version 1 in my test earlier. So I didn't want to cause any problems. Basically overriding that. And then we pushed this image. We pushed the version 10 of our image up to our Docker registry. So it's there. Our Docker image is there. It's waiting to be deployed to Kubernetes. We're just going to use Terraform to do that. Now, obviously, you could use kube control. Something like create deployment -- image, and then you type in the name of your registry, the name of your image, and any other commands, any other options you want to apply to that. So we can use kube control directly to manually create this. I'm not doing that. I'm using Terraform to do it. The reason I use Terraform to do it is because then it's like, instead of just being, like a shell script with, running kube control in the continuous delivery pipeline, we've got a proper language there for configuration. And it's really smart. Terraform is really smart as well. It knows the current state of your system, and it knows the changes that you want to make to get it there. And kube control just isn't that smart. Even though we're using kube control under the hood, we're using Terraform, but under the hood we'll be using kube control. So let's have a look where we are with the Terraform code. Close these files. So just under the scripts directory of this repo here, all the Terraform files, and then just some helper shell scripts that I'll show you in a minute that help us kind of put all this together. This whole thing is designed to run on a continuous delivery pipeline. So it's got some backend set up here, which is what configures the state, the storage, like the backend storage for the state of the continuous delivery pipeline. I don't need this running locally. In fact, it's going to cause problems because it might confuse it might use that persistent state of my live continuous delivery platform as my local state. I don't want that. I just want it to have completely local state. So I'm commenting out the code that's in backend.tf here. Now, to use Terraform, I've got to be in the same directory as the Terraform scripts. So I'm going to cd down to the scripts directory. Have a look there. That's where all our Terraform scripts are, and the shell scripts as well. I'm just going to check what version of Terraform I'm using, because the thing is, I'm using, for this demo, I'm using an old version of Terraform. I'm using version 0.12. But for my production work at the moment, I'm using 0.14. But I haven't upgraded my demos to that yet. So I'm just going to stick, for this demo, I'm just sticking with version 0.12. And whenever you clone a fresh Terraform project and you want to run it locally, you've got to run Terraform init. If I can spell it right. There we go. That's better. So this is downloading all the plugin providers that I need to use, like the Kubernetes provider. I don't know if I need these. No. So the reason that Terraform can work with any different type of cloud provider and also work with Kubernetes is because it's all driven by plugins. So there's plugins for any kind of thing you want to connect to and any kind of thing you want to configure. At least all the main ones anyway. So we have initialized now. What that means is that we'll have a low. Let's do an ls minus l so you can see everything. Oh, you can't see the hidden files. That's all right. But if we do an ls in the Terraform directory, so it creates a hidden directory called .terraform, and in there is where it downloads all the stuff that it needs. Now, if I run Terraform apply, it's going to automatically. Let's just show you. So it's gonna look at all the TF files here, and it's going to execute the code in these Terraform files, right? But I've got some inputs. I've got some variables I need to provide it, like this one here. I need to tell it where to find my Docker registry. Now I could enter that all here, like let me show you. I'm just copying and pasting my registry name in. That's all good. But the problem is when I get to this point where it asks for the certificates, like the keys that I need to authenticate with my Kubernetes cluster, if I try to copy them to the command line, something goes wrong. It corrupts the key or something like that. It doesn't seem to work. So I'm going to create a little batch file to do this. Now again, I'm only demonstrating how to do this manually. So the ultimate aim is to do this all automatically. And so you won't be sitting here typing stuff at the command line. You won't have to be creating these kind of batch files and stuff like that. But let's just go back to code, Visual Studio Code here. I'm just going to create a new file called deploy-local.bat. This is a batch file because I'm just running it directly under Windows here, so I can't run a shell script unless I open a Ubuntu terminal. So I do have Ubuntu running as a virtual machine on Windows 10, but I'm just going to keep things simple. So we want to run Terraform apply. I'm going to set it up to auto approve. Otherwise, you have to type yes, and that takes a lot of time, doesn't it? So we want to speed this up. So we're going to auto approve the changes we're going to make. I'm just using the line continuation character here. So we're spreading one command out over multiple lines. Now I'm passing in variables directly. So this is sort of how we get this running on continuous delivery as well, is that we've got to wire in all the variables that we want to pass in. So the first one, in fact, let me look at my variables file. So this TF file here is just all the variables that I need. Not that one, that's the wrong one. So these are all the variables I need to supply. So I can kind of just copy and paste these across to get this running. So my Docker registry, let me just grab the name of that again. So that's the first variable that I need. The next variable I need, what's the variables that we're going? So the next variable I'll have is the service name. So we're calling this sort of test version video instead of video streaming. The next variable I need is the version. So that is going to be version 10. So that's the version that we published that we want to get on our Kubernetes cluster. Now I have to give it the authentication details. Now I have to give it the connection details it needs to connect to my Kubernetes cluster. So I'm just going up to my cheat sheet to just get some of these details because they're quite big, and you're not going to want to watch me type these in. So this is the Kubernetes host that we're connecting to. Now comes the interesting bit. I need some of these certificates and connection keys, and these are the big ones. These are the ones that if I cut and paste these directly to the command line, somehow it corrupts them. I'm not really sure why. By the way, all these details that I'm typing in for connection with the Kubernetes cluster, if you watch the first version of this video, you will see how I got these. You'll see how I built my cluster and how that process of building it, the output of that was all these keys that I needed to connect to that cluster. Now, hopefully this is all good and I have not typed anything wrong. I've just got one more, this CA certificate. I think that's all I need. So now I can run this batch. Oh, I need a line continuation there. Do I need one there? Yep. Do I need one there? Oh, I've got one there, cool. So that's all good. Let's just close down this variables file so you can see this whole thing. So this is the command, Terraform apply, auto-approving it, otherwise we'd have to type yes at the command line. And we're passing in a whole bunch of variables to use within the Terraform code, the things that it needs to be able to connect to our infrastructure and deploy stuff for us. So I'm just going to run this. Fingers crossed. Oh, before I do that, I'll just show you the pods that we've got running already. So these are the containers that are already running on my Kubernetes cluster. There is just this single video streaming one, but after I've deployed the new one, I should see one here that's not video streaming, it's just video. It's going to do the same thing. I'm just doing a demonstration to show you that I can do this. Oh, I don't want that. I want the deploy script. So I'm running the deploy batch file that I just created. Oh, sorry, deploy local. Have I missed a line continuation character here? That's really weird. I don't know what's wrong with that, but I'm just going to get rid of these line continuation characters, just put it all on one line. Hopefully that will avoid me having to figure out what's actually wrong with it. Okay, let's try that. Run it again. Fingers crossed. Praying to the demo gods. Oh, it's looking good. It's creating something. Now, hopefully this isn't going to take too long. While that's going through, actually, let's have a look at the Terraform code that makes this possible. So, you've seen the variables file. You know, that's where a bunch of variables are set up. You could put defaults in here, like you could say default equals, you know, some default of this variable. But the fact that we haven't got defaults there is why you have to provide them. Why you have to provide them at the command line. And so you're forced to provide that configuration. The provider's Terraform file is basically just where we set up Kubernetes. So this is where we're using some of those variables. So the keys here, we're plugging these into our like our connection details for our Kubernetes cluster. We've got this is the important one. So this is the Terraform code that actually deploys our microservice. There's two parts to this. There's the Kubernetes deployment and the Kubernetes service. A Kubernetes deployment is something that basically manages a replica set for us and a bunch of pods. Now we're only kind of instancing one pod here, but you could instance as many as you want. And this deployment is basically responsible for keeping them alive. If any of them die, it's gonna boot them back up again. So we start with a bunch of metadata here. Here is the spec for the pod. This is the number of replicas. So we only have one of these things running. We could easily change it to 3 or 30, however many you want. If you want like a load balanced microservice that has many workers, really easy to kind of scale up using Terraform and Kubernetes. And here we've got the template for the container. Down here is where we're plugging in the image. So again, here we're making use of variables. We're composing the image name of the Docker registry, the service name, and the service version. So that's using Terraform interpolation to basically build that string and get that thing for us. And it kind of means we can, if we wanted to, we could reuse this Terraform file for other microservices, and we just plug in the name. We just plug in the name of the thing that we're deploying. So it's a fairly common configuration. There's an example of an environment variable configured here, which tells the microservice which port it's going to use. And we can configure other environment variables here, other environment variables that we might need to plug into our microservice. Now, if you want to access this first part, this Kubernetes deployment, that deploys our containers into the Kubernetes cluster. If you want to have them accessible via DNS, you have to put a Kubernetes service on it. So that's what makes it exposed internally. But what we're doing here is at the end, this last bit is important because adding a type load balancer is what provisions a load balancer, an external load balancer in the cloud vendor so that we can get external access. So if this was going to be an internal microservice only and you didn't want to access this from the outside world, you just delete that and you have it like that, and it's just an internal private microservice, which can be good for security. Most of your microservices in your application are probably going to be internal only, and only because we want to get to this from the outside world so I can show you that it's working do we put the load balancer on there. But you know, if this was your web server, if it was your gateway microservice, something like that, you also want to do this. You also want to do this so you can expose it. Okay, let's have a look. Cool, that's gone through. If I do kube control get pods now, we should see our video pod here. We can also do, if you want to see the actual deployment that's looking after that pod, you can do kube control get deployments. So that shows you there's a deployment after that as well. Now let's look at the external IP address for this. If I do a get services, you can see we've got two external IPs. This one here is the external IP for our latest one. So we can have a look at that. It should give us hello computer. Great. We should have a video route. Great. We've just manually deployed a microservice. I can clean up after myself now. I could run Terraform destroy. Now I have to give it all those same options as apply. I'm not going to run through that now because we're running out of time. But doing Terraform destroy will just clean up the things that I just created, which is just this. It would clean that up, that video pod. It would not touch this video streaming pod because that's owned by a different Terraform pipeline. So just quickly now, how do we get this into continuous delivery? We need this YAML file. So GitHub has a similar YAML file for GitHub Actions. GitLab has a similar thing, and so do the other continuous delivery providers. So it's really simple. That's all it is. Like, I like to say that continuous delivery is simply running a shell script on automatic in the cloud. In this case, we're running multiple shell scripts. But the first thing to note here is that this whole, the container that's booted up to run this continuous delivery pipeline is running on Terraform 12. Okay, that's the first thing to note. We're also using some special configuration here for Bitbucket pipelines to pull in Docker. So that's what allows us to use Docker as well as Terraform in this case. And what we're doing here is we're running a shell script to build the image. We're running a shell script to push the image. I'm not going to show you these shell scripts because we're running out of time. But all this build image does is the Docker build command that I showed you earlier. And all this push image shell script does is the Docker login to the registry and then the Docker push to get it there. I will show you deploy.sh. So this is the shell script that actually runs Terraform and does the deployment. And that's simply doing what I just showed you that we did. We're doing a Terraform init. There's some extra parameters here that manage the state and persist the state of the continuous delivery pipeline. Don't have time to explain that at the moment, but we're just doing the Terraform init, and then we're doing the Terraform apply with the auto approve, and we're wiring in all our Terraform variables from global variables. Now, these global variables, environment variables, are basically, in Bitbucket, they're called repository variables. We can configure them securely on the repository and pass them in such a way that we don't have to keep them in the code. If you're using GitHub Actions, you're looking for GitHub secrets instead. These things will come from GitHub secrets. So that's it, really. Continuous delivery just runs a bunch of shell scripts that, use Docker build, use Docker push, use Docker init, and then use Docker apply. So we've covered a lot very quickly, but this is what we get to. This is where we get to when we've got this thing online. We enable the Bitbucket pipelines so that then we can automatically push code and have that code flow into production, just like I showed you at the start of this talk. So that's really it. That's the demonstration over. I'm slightly 30 seconds under an hour by my count, so I've got to wrap up really quickly now. Basically, you're using Docker to build and publish. We're using Terraform to create and update our cloud infrastructure. And if you take anything away from this, it's that infrastructure is code. It's just managing your infrastructure through coding. And we can develop and test our code locally, but the ultimate aim then is to push that code into our continuous delivery pipeline where we're going to run it on automatic. Continuous delivery is just a shell script. It's just a shell script running automatically in the cloud. That's a massive simplification, of course, and some providers offer way more than that, of course. But if you're struggling to understand what continuous delivery is, just start with that. That's the most basic thing I can think of to explain it. And lastly, infrastructure as code is one of these things that really helps make microservices cost effective. Like if you think microservices are expensive to build and run, you're living in the old world. Come into the modern world. Try the modern tools. Try building cheap cloud infrastructure. Microservices are very cost effective these days. So, this talk's really only been a taste of what you can do with infrastructure as code. If you'd like to explore the bigger picture of building a microservices application with modern tooling, you can't go past my book, Bootstrapping Microservices. It's very practical and straightforward. It walks you through the whole process of building an application, all the way from building and publishing a single microservice to building your entire application and publishing it in the cloud, and getting your application into productive. So what you end up with are the skills to go all the way from development through to operating your own application in the cloud. And I like to keep things as simple as possible in the book. And in any way that I'm teaching, I like to keep it simple. And the example application, it's not overwhelming, it's easily understandable, and you can deploy it for yourself to the cloud. But at the end of the day, I'm making things simple. I'm cutting some corners, but I'm doing it in such a way that we're still using microservices. So we still have these pathways to scalability that weren't possible otherwise. And at the end of the book, there's heaps of practical advice on how to scale your application in multiple dimensions. So that's it for today. Thanks so much for listening. This has been part 2 of Infrastructure as Code. You can find part 1 on YouTube, and you'll find this one on YouTube very soon as well. If you only just caught the end of this and you want to see the start. My book, Bootstrapping Microservices, goes into this and takes you through all this in detail. So please take a look at it. I showed a discount code a moment ago. If you missed that, you can look it up on YouTube at the end of this video later. And just be aware as well that I'm live streaming my coding every week now. So keep an eye on my own Twitch, my own personal Twitch channel, Ashley Davis. I'd love to see you there. Come and watch me do some coding. Come and watch me make some horrible mistakes, and watch how I recover. Watch how I never give up. Anyway, thanks so much for listening. It's been great to be able to talk to you all. And wherever you are in the world, however you're faring against the pandemic, please stay safe. I wish you all the best. Bye-bye.